A hypoglycemic attack, which is when a person with diabetes blood sugar drops too low, can be dangerous if not treated quickly. It's more common among people with type 1 or insulin-dependent diabetes, and one danger is at night when people might not wake up to their symptoms. A new non-invasive device is making it easier and less painful to detect hypoglycemia, and it's part of a new wave of non-invasive health technology, which may have a dark side. Ellen Liebeter has more.
This is the device.
So it just sticks on your chest?
Yeah.
Fits under your shirt, you can't even notice it?
Yeah, you can't even notice.
This is the lab of Professor Hung Nguyen. He's the director of the Centre for Health Technologies at the University of Technology, Sydney. He's putting a glucose monitor on his chest, a small circular device that fits in the palm of your hand.
People with type 1 diabetes have problem because insulin can cause low blood sugar, and they have problem with dead in bed syndrome. That is a very frightening condition because of never wake up in the morning.
Type 1 diabetics have to test their blood sugar levels every few hours by pricking their finger with a needle and putting a drop of blood through a blood glucose monitor. But Professor Nguyen's device does away with all of this. In fact, his device doesn't even use blood to test blood sugar levels. This is your smartphone you've just pulled out.
Yes.
So what are we looking at on this app?
You can see the heart rate, ECG, and from this it decides for your blood glucose level.
The device uses artificial intelligence to take all the data from your heart signal and identify when you experience a hypo. It then connects to an app on your smartphone and sounds the alarm if your blood sugar drops too low, preventing dead in bed syndrome. But Professor Nguyen hasn't stopped there.
Our brain uses a lot of sugar. So when you have hypo, very severe hypo, the brain just shut down. Brain is the early and consistent way to look at the blood glucose.
Professor Nguyen is now looking at how AI can take your brain signals and identify when your blood glucose level changes. And he predicts this device will be even less invasive than his blood glucose monitor that sticks on your chest.
We start with the headband, but eventually maybe something underneath the hair can do similar things.
Developing an algorithm to decode your heart signal is one thing, but decoding brain signals is a different ballgame altogether. Think about all the bodily processes your brain is controlling at any given time. And now think about how hard it is to pinpoint the signal that controls, say, blood glucose. And this is made even more difficult because the device is not located directly on your brain.
Non-invasive technologies are always difficult. Why? Because the signal is a lot smaller. A number of different people in the world, in order to do brain-computer interface thought control, they have to open up the skull and put sensor directly on the brain. And it's a very invasive, but gives you very strong signal.
If you can just put a device straight on the brain to fix these, it's invasive, but it's going to help people's lives. So why don't we just do that? Why non-invasive?
You have to do surgery. And you find that people have that and they have wires hanging out. That sort of thing is very dangerous. So non-invasive is the way to go.
The potential applications for this technology are endless. Professor Nguyen has previously developed a thought-controlled wheelchair for people with disabilities. But in order for any medical device to decode your brain signals, invasive or not, it needs to learn how your individual brain works using complicated machine learning algorithms. And this is where using AI in medicine has people concerned.
We actually can design AI so it has the mind of its own, and I already proved that. I can get a system and let it running wild, and 3 months later, I would not recognize it. And I have done that. AI will move in a direction that we may not be able to understand.
Professor Nguyen isn't the only person worried about algorithms running wild. It's a fear shared by Tesla and SpaceX CEO Elon Musk, who earlier this year called on the United States to start regulating artificial intelligence.
I think we should be really concerned about AI. AI is a rare case where I think we need to be proactive in regulation instead of reactive. Because I think by the time we are reactive in AI regulation, it's too late.
The European Union has already made inroads on adopting civil laws on robotic rules, including ensuring safety of new medical robotic devices. Australia has no such plans to regulate AI, but any medical device still has to conform to TGA standards.
The AI, we're very conscious of safety. The regulatory people are safety conscious as well, and we have to conform, and that's a good thing.
Most of the machines Professor Nguyen has developed have the capability to self-learn, but he will lock up an algorithm once it's reached a certain level to ensure it doesn't run wild.
We stop when it learns to a certain optimal, and then we stop because otherwise we don't know whether it go backwards or not. We're afraid of the algorithm going worse. And then when we actually let it go again to improve, it has to improve better rather than going backwards.
In addition, if these medical devices do have a glitch, they can revert to a safe mode, where they still work, but within certain limitations. Ethical concerns notwithstanding, non-invasive health tech is marching forward, and it's a market Professor Nguyen predicts will be worth trillions of dollars.
It will be very big. It will have a lot of applications. It will be everywhere now.
Ellen Leabeater was speaking to Professor Hung Nguyen from the Centre for Health Technologies at the University of Technology, Sydney. And Ellen Leabeater is the Health Report's producer. I'm Norman Swan. You've been listening to the Health Report, and I hope you can join me next week.